We're starting our new unit on quadratic functions. Hopefully you remember from the last unit that quadratic functions will always have an exponent of 2. So follow along with me on your discovery here. And first we want to look at what shape quadratic functions make. To do that, we are going to plug in these numbers and graph it to see what shape it would make. This is a quadratic function. It has 2 as the highest exponent. So I'm going to plug in -4 squared minus 1, -3 squared minus 1, -2 squared minus 1. So I'm plugging in all of these values for x. And then we're going to see what shape that it makes when we graph it. So 1, 2, 3, and 4. Okay, so first of all, -4. Now what happens when I square a negative? If it is in parentheses, this is going to be -4 squared is going to give me positive 16 minus 1. Okay, -3 times -3 is going to be a positive 9. -2 times -2 is going to be a positive 4. This is 1 minus 1. 0 minus 1. Then we have 1 minus 1. What do you notice? We've already had 1 minus 1 before. Here I'm going to have 2 squared minus 1. That's going to give me 4 minus 1, which we've already had before up here as well. Then I'm going to have 9 minus 1, which we've already had. And I'm going to have 16 minus 1. So this is something that we have not seen in our linear or exponential functions. We haven't seen where we get the same y values out for different x values. So I'm going to graph these points, these x and these y points, so -4 up 15. I'm going to go over to -4 and 15 is going to be on this thicker line. -3 up 8 is going to be 2 below the 10. -2 up 3 is going to be right here. -1 up 0, 0, -1. 1, 0, 2 up 3, and then I'm just going to finish plotting these points. So this is the shape that our quadratic functions are going to make. So I wanted to ask you, is it a U or a V? If it was a V, then that would mean I could draw a straight line here between the points. So it is not going to be a V, it is going to be a U-shaped. Okay, so we need to make sure that it's nice and curved, a nice curved U shape. And then let's connect the points here. Okay, a nice curved U shape. Does anybody know what the proper name for a graph that makes this U shape is? The proper name is a parabola. It's hard for me to draw on this thing. Okay, so the shape that it will make is a U shape, which is called a parabola. Parabola. And again, it is not a V shape, it is a U shape. Quadratic functions are symmetric. What does that mean? That means they are the same on one side as the other. So they are all going to have what's called an axis of symmetry. So let's look at where this graph is symmetric. What could I draw that would split this graph in half like a mirror? What type of line could I draw that would split the graph in half so that it is like a mirror? It would be a vertical line down the middle. Okay? And our quadratic functions are always going to have an axis of symmetry that is a vertical line. Okay, it's always going to be a vertical. It's always going to be a vertical line. And what is the equation of a vertical line always have? The equation of a vertical line always has x equals just a number. So whenever I ask you for the axis of symmetry, you should always give me x equals a number. The way you can remember that is that if I ask you for axis, there's an x in the word axis, so it's going to be x equals. What is the axis of symmetry of this function above? It's going to be x equals. Axis of symmetry always has x equals. And what is the equation of that red line that splits the graph in half? In this case, it is x equals 0. Quadratic functions are always going to have what's called a vertex. Can you guess where the vertex would be on this graph? The vertex is going to be the lowest point for this graph. Okay, vertex is going to be an ordered pair. Axis of symmetry is always an equation of a line. Vertex is going to be an ordered pair. This is the ordered pair 0, -1 is the vertex. The vertex is always going to be a maximum or a minimum. So remember, maximum would be the highest point, minimum would be a lowest point. This parabola would have which one, do you think? This one has a minimum. Okay, and a minimum, again, it's going to be an ordered pair. It's going to be a minimum at 0, -1. So do you notice that the minimum is going to be the same as the vertex? Occasionally, we would have a quadratic function that has, instead of a minimum, a maximum. How could we get a quadratic function to have a maximum? Well, it would need to be flipped upside down, like this. Okay, we're going to see some of those where the vertex is a maximum. Quadratic functions will have a y-intercept. What do we always remember for y-intercept? I hope you remember for y-intercept, we always remember x equals 0. I told you that was going to keep coming up over and over and over. Okay, so x equals 0 for a y-intercept. Why do you think there will only ever be one y-intercept for a quadratic function? The key word there is because I said quadratic function. In order for something to be a function, if I had more than one y-intercept, is it possible for this to be a function? No, it would not pass the vertical line test. So it will always only have one y-intercept in order to pass the vertical line test. Okay, so every function will always have only one y-intercept. All functions will only have one y-intercept. What is the y-intercept of the function above? The y-intercept is going to be an ordered pair with x equals 0. Okay, and let's take a look at where it crosses the y-axis. It's right here at the point 0, -1. Okay, you should notice that that is the same as the vertex and the minimum. Okay, do you think that all of my parabolas will always have the vertex be the same as the y-intercept? No, it might not always be. It just is in this case. Next, quadratic functions sometimes have 0, 1, or 2 x-intercepts. We are going to be talking about x-intercepts a whole lot in this class. You need to know some other names for x-intercepts. I might ask you for x-intercepts, but here's some vocab. Other names for x-intercepts are going to be called roots or zeros. Okay, so if I ask you for roots or zeros, that is the same as asking for x-intercepts. Now notice, it is okay for it to have 0, 1, or 2 x-intercepts for a quadratic. It will only have one y-intercept, but you could have 0, 1, or 2 x-intercepts. It says, what are the x-intercepts of the function above? So where does it cross the x-axis? This one has got 2 x-intercepts. I've got one at -1, 0 and +1, 0. What do we always remember for x-intercept? We always remember y equals 0. So -1, 0 is a root, And positive 1, 0 is a root, or 0, or x-intercept. So our quadratic had 2 x-intercepts, but occasionally there might be 0 or 1 or 2. So let's, it says draw an example that would have 0, 1, or 2 x-intercepts. Okay, so I want you to draw 3 axes like that. We already saw what it looked like to have 2 x-intercepts. Okay, this was what it looked like when we had 2 x-intercepts. Let's think about how I could make a quadratic. How could I make this have just 1 x-intercept? So if I move this around, look at this and see if you can tell how it could have just 1 x-intercept. Does anybody know? Hopefully you figured out that if the vertex is right on the axis, then it would have just 1 x-intercept. This has 2 x-intercepts. This has 1 x-intercepts. Now let's figure out how to make it have 0 x-intercepts. How can I make this not have any x-intercepts? If I move this down here, that won't work because it keeps going forever. Okay, you might think, oh, well, I could flip it. Some of them are going to be upside down. Okay, if I flip this right now, this does not have any x-intercepts. So that is an example of a quadratic that has 0 x-intercepts. In this class, most of our quadratics are going to have 2 x-intercepts, but as you move up in your math classes, you're going to look at more that have 1 or 0 x-intercepts, especially in Math 2. Okay, on the next page, it says find each for the quadratic function. This is a quadratic function. The vertex is going to be this point right here, so that's the point -2, -1. The axis of symmetry, what did I tell you to always remember for axis of symmetry? You should always remember x equals. Why? Because axis is always a vertical line. Okay, so I need a vertical line that would split this graph in half. Okay, and what vertical line? This vertical line would split this graph in half. Okay, where does that cross the x-axis? It crosses the x-axis at -2. Okay? Roots, what are roots the same as? Roots are the same as x-intercepts or zeros. Roots are, since x-intercepts, we always remember roots, we always remember y equals 0. They're going to be ordered pairs. So we have the ordered pair -3, 0, and we have the ordered pair -1, 0. And the y-intercept, what do we always remember for y-intercept? We always remember x equals 0. So let's look at where this crosses the y-axis. It crosses at 0, 3. Okay, number 2, the vertex is going to be this point. In this case, it's a maximum. What is the ordered pair to get to that point? That is the ordered pair 0, 3. The axis of symmetry needs to be a vertical line that cuts the graph in half. This is my axis of symmetry. Axis of symmetry will always have x equals because it is a vertical line. And we want to look at where it crosses the x-axis. It crosses the x-axis at 0. What are zeros? Zeros are the same as roots or x-intercepts. This has a 0 at -1, 0, and it has one at +1, 0. And the y-intercept is at 0, 3. Number 3, the vertex is right here. That's at the point over 0, up 1. The axis of symmetry is a vertical line that would split it in half. Axis of symmetry always has x equals. And this is going to be x equals 0 as well because that's the line that splits it in half. Where does this graph cross the x-axis? This one actually has no x-intercepts. And the y-intercept is 0, 1. So the y-intercept will not always be the same as the vertex. That's only going to be if the vertex is on the y-axis. Something I do want to point out, though, is first of all, the x in the axis of symmetry is always going to be the same as the x in the vertex because the axis of symmetry will always go through the vertex. Something else I want to point out is I want to look at what you think would make the graph be upside down. Okay? See if you can look at these equations and see if you could tell what would make the graph go upside down. Hopefully you notice that this one has a negative in front, and that one is upside down. So that is something else important to notice. If there is a positive in front of the x squared, it's going to open upwards. If there is a negative in front, it's going to open down. Okay? This one is going to take a lot of work and a lot of space. It says fill out the table and graph for this function. Okay, this is going to be a parabola. I know it's going to open down because there's a negative in the front. We're going to need to write really small, and I'm going to plug these numbers in for x. Negative 2 times 2 squared plus 4, or times negative 2. So make sure you write this small. I am going to copy this. Sorry, you can't do that on your paper, but I'm going to because I can. And then we're going to fill these numbers in for x. We need a lot of space, though, to work these out. And I'm going to plug all of these numbers in for x. Okay. So I'm going to plug in negative 2. I'm going to plug in negative 1, 0, 1, 2, whoops, I skipped over the 2, 2, 3, and 4. So go ahead and pause the video until you get all of that copied down, and then we're going to figure these out together. When you go to figure these out, it is very important that you do the order of operations. So when I do this, would I do negative 2 times negative 2 and then square it? No, if I do the order of operations, PEMDAS, I need to make sure to do the negative 2 squared first. That gives me positive 4. So always do the exponent first. Okay, 4 times negative 2 is negative 8 plus 6. That gives me negative 8 minus 8 plus 6, which is negative 10. So as you are figuring these out, again, it is very important that you always do the exponent first. Always do. These are always going to have a 2 exponent. Always do the exponent first. This is negative 2 minus 4 plus 6. Negative 2 minus 4, same sign, add and keep, is negative 6 plus 6 is 0. Again, exponent first, always. 0 squared. So negative 2 times 0 plus 0 plus 6, that's just going to be 6. Exponent first. Do the exponent first for all of these. 1 squared, exponent first. Negative 2 times 1 plus 4 plus 6. Negative 2 plus 4 plus 6. Okay, this gives me 2 plus 6 is 8. Okay, pause the video if I'm going too quickly for you. 2 squared is 4. Make sure we are doing the exponents first. Negative 2 times 4 plus 8 plus 6 is negative 8 plus 8 plus 6. That cancels out to give me 6. Should notice we already had a 6. So what do you think the next one is going to be? Let's see. 4 squared here gives me 16. I skipped over. Why do I keep skipping over these? So this is negative 2 times 9 plus 12 plus 6. That is negative 18 plus 12 plus 6. Does that give me 0 like we guessed? It does. Negative 2 times 16 plus 16 plus 6. That's negative 32 plus 16 plus 6. And that does give me negative 10. Okay, it takes a lot to work out these questions. You have to make sure that you always do the exponent first. Okay, I'm going to graph these points. Negative 2 down 10. It's going to be down here. Negative 1 up 0. 0 up 6. 1 up 8. 2 up 6. 3 up 0. And 4, negative 10. So were we correct that this one opened downward since there was a negative in the front? Yes, that's always going to be the case. It's so hard for me to draw on this thing. But I'm going to do my best to sketch a nice parabola. I'm going to make sure to put arrows on the end because it is going to keep going down forever. Okay, let's look at the vertex. The vertex is always going to be an ordered pair because it is a point on the graph. The vertex is going to be at 1, 8, right here. Axis of symmetry, we said, will always have what in it? It will always have x equals because it is a vertical line. Let's look at what vertical line will split this graph in half. This is the vertical line that will split the graph in half. So where does that go through the x-axis? It goes through the x-axis at 1. Okay, remember, it's always going to be the same as the x in the vertex. Does this graph have a maximum or minimum? The vertex in this case is the maximum. Where is the maximum? The maximum is at the point 1, 8. It's the same as the vertex. This does not have a minimum. It keeps going down forever. Now, let's talk about, you can see the vertex in the table, okay, because the vertex is going to be the number where all the numbers are repeating around it like this. So if I gave you a table and asked you for the vertex, that's how you would find the vertex and the maximum. The y-intercept, what do we always remember for y-intercept? X equals 0. So x equals 0 is the point 0, 6 here. You could look there or you could look on the graph. Roots are the same as x-intercept or 0. That's where y equals 0. So you could look on the table for y equals 0, or you can look at the graph. This has roots at -1, 0 and +3, 0.